stopped the recording in between. I start and then I have to share. Okay. Okay, now the screen is visible, no? PPT is visible now?
Yeah, ma'am, it's visible.
Okay. So in the first fit search, how the searching happen? Operating system, but in operating system, there is a separate segment called the memory management unit, MMU. We usually call that as a MMU, memory management unit. That memory management unit only will perform the scanning. Okay. Scanning matlab searching it will only perform. Okay. So in the first fit, it will search starting from the first list item in the linked list memory. Okay. When it finds the suitable memory space, at first, it will allocate the process there. Okay. MMU will allocate the process in that hole. Okay. That is first fit. Okay. Okay. To allocate the actually after found the free space, how the allocation will happen. For example, this is the free space got found. Okay. By the MMU for a particular new process. Okay. It will change this whole to P. No. Now it has to change to P. Okay. And the size will be here. The size should be changed accordingly. Okay. For example, now 3 units. Now new process needs only 2 units. Only 2 units. So the 2 units of memory will be used. So here it will be mentioned 2. Size will be 2. Okay. So, and then the pointer will point, of course, the next link. So this is the change it will do, MMU will do. This is first fit. Next fit is like MMU will search. When new process comes, it will search. But whenever it finds suitable hole for the process, it will just keep track of that hole which it was found. Okay. For example, one process is coming. Okay. In the next fit will also initially the next fit will also start to search from the first only. Okay. Assume that in the first process it finds this is a suitable hole. Okay. After it found and it allocated, it will remember. It will remember. That means the pointer will be there, separate pointer from where it left. That means where at last it found the free space. And then next new process comes, it will not start to search from the first list. Okay, first list item. Okay, it will start from where it left. For example, here it left, no, it will start to search from here. Then assume that here it finds the new space for the second process. It will allocate here. It will remember this process. Remember means there will be a pointer that will point this one. Okay, this entry. Okay, so that we can say that will remember in the next fit, the previous allocation will be remembered. And next new third process comes, it will start from here. Okay, like that the searching will happen in the next fit. But what happened in the first fit, always whenever new process comes, no, the searching will start from the first list of the linked list only. From the first list of the linked list only, it will start the searching. For example, in the first fit, FIRST, first fit, it finds this is a suitable hole. When new process comes, again it will start to search this, starting from here. Okay. So that is the only difference between first and next fit. Everything else is same. Okay. But next fit is not commonly used. Okay, it is not commonly used. It is theoretically only it is there. Okay. So next fit not commonly used because that searching will not help, will not give any advantage. Okay. So that is not used, but in your book it is mentioned. Okay. Next, best fit. You can easily guess what would be best fit. Best fit is like any new process arrives, the MMU will completely scan entire holes. Entire holes. It will go sequentially searching, but it is called the exact scanning process. Complete the linked list will be scanned, okay, and it will be compared, which is best suitable fit, which will not waste any memory, which will not waste any memory. That kind of space will be found and the allocation will be made. Okay. For example, there is a here the example is not proper. 3, 2, 3 they have given. No. Okay, let it be. So assume that 1 kilobyte process comes. 1 KB process is coming. Okay. So by following the best fit, the complete the linked list will be scanned. So this is one free hole and this is another free hole and this is a third one. Only 3 free holes are available here. Okay. Now in best fit, as the new process size is 1 KB, if it allocates here 3 KB will be wasted. If it allocates here 2 KB, sorry, if it allocates here 2 KB will be wasted, here also the same. Okay. So it will allocate here, then only it will waste what? Only less uh, space, free space. That is best fit. Okay. So it will find the free hole to allocate the memory, which is very closely what? Which is very closely the suitable size of the newly arrived process. Okay. Then what would be the worst fit? That also you can guess. Worst fit. To overcome the disadvantage of best fit may what chota tiny free spaces, no, that will be wasted. Okay. Because in best fit it is finding nearly closed size, the free hole which is having nearly close size of the newly arrived memory. Okay. For example, newly arrived process is 3 KB. It will find exact 3 KB is there or 4 KB is there. Okay. So it will allocate 4 KB. If 4 KB hole is available, it will allocate immediately. So of course, it is not the exact size, no, the whole size and the new process size is not exact. So there will be small, tiny free space. But what will happen? Those tiny free space cannot be used by any other processes. Cannot be used by any other processes. Okay. Such a tiny free spaces will be left over. Okay, that is a disadvantage of best fit. Then in the worst fit, it will find which is the very largest space, free space. There also scanning will be done same as best fit, but it will find the very largest free hole and it will schedule the process. It will allocate the process in that hole. Okay. What is the use here? The free space which we will get to know after allocation, that will be in big size normally, usually. Okay. So any other process comes, the process can be allocated in the free space. Okay. So that is called a worst fit. Worst fit. Okay. In the best fit, there are many tiny free spaces will be wasted, which cannot be used by any other new process. But in worst fit, after allocated, that means, but before allocating it, the single linked list will be splitted into two, remember. Okay. One will be the linked list allocated one, another will be whole. Understand? For example, here, assume that here, the middle one. Here, but this is not suitable for worst fit. But let me just for example, I'll say, okay, new process arrives, that process size is Can we assume here if it is 4? Then only it will be suitable. Okay, assume that there is a process, it is coming, which has 1 kb, which has 1 kb as a size. So what are the free spaces are available? This one 3, this one we assumed 4, this one 3. So in worst fit, which will be selected? The largest one, 4 will be selected. Okay. So 4 may 1 kilobyte will be allocated for the process. So this linked list, will be changed to P18 and this will be 1. Okay. Again, another linked list will be inserted. This linked list will point to that linked list and that linked list will have H whole and starting address of the whole. Okay. Suppose if it is 18, that would be 19 because it is 1 kb allocation we made, so 19. And then size will be what? 3. Why? Here only 1 we allocated and then 3 free space. Okay, so the linked list item will be inserted accordingly. Okay, that you have to remember. So these are called searching methods in a linked list. Okay. In between one diagram was there, that also actually mentioned in your book, that is this one. Here they are saying if any process got deleted in a linked list. So linked list, if any process deleted, how the linked list should be updated. How the linked list will be updated. Okay. Assume that X is the process which are getting deleted. Okay, which is getting deleted, X. Okay. So there are 4 possibility where it would be located before. Okay. One is both the side of the X, there could be 2 processes. Okay. Or one side of the X is also process, students. X is also process. Why we are considering this process, though we have other processes? Because we are going to delete this process, assume. Okay, this process we are going to delete. Okay. So the process would have been there like this, surrounded by 2 processes in the memory. Okay, or the process which is going to be deleted would have been like this, one side a process, another side empty place, or otherwise this side empty space, other side the process, some other process, or it could have been both the side surrounded by the empty space. Any one of these 4 possibilities only possible. Okay. So if it is there, if it is like this, if it was like this, that becomes like this. Okay. So after deleted, both the side process will be there, both the side process. Of course, this process, students, here they put only A, but there are 3 divisions here. Remember, one is what? This is occupied process, no? So P, starting address, length, that will be there here. Okay. So the same 3 components had been there here also. Okay, but it got deleted. And B will also have the P process and starting address of this process and the size of the B. Okay. Now what we have to do if this deletion, the deletion happens like this, what the MMU will do, it will just this one segment, that means the list item, it will keep as it is and it will keep only change in the 3 elements. One is H. Of course, the starting address will be same and the segment, the size of the segment will also be same. Okay. But only the P will be changed to H because already it was there, the process was there, that's why it was P. Now we turn to whole, no, deleted, no. So the P should be changed to H. After deleted, the starting address and the size may no change. Change will not come. Okay. That is here. In the second case, first process, that will be as it is. Next, our deleted process. And next to deleted process, there was a empty space, no, whole. So both will be merged like this. Merged like this. Now this will become one entry. Remember, after deleted, this will become one entry. In this entry, it was before here it was whole. Okay. It was whole, no? So no, it was a process here. Okay. So P will be changed to H. P will be changed to H. And the starting address will be as it is, size will be changed. Size will be changed because size is extended, right? So size will be changed. Okay. If it was like this, then after deleted this two space will be merged and you will get the space like this, and B will be as it is. Okay, here what should be done? In the initial here in this segment data item, it was H only, so it will be H. Starting address also same, starting address also same, but size will be incremented. Size will be incremented. Here what should be done? After deleted the process, already the process was both the side of the process were this only, empty space only, holes only. So everything will be merged together. Now the three components will become only one entry. Three entry will become one entry. And the starting address will be as it is and the whole will be as it is. But the size will be changed accordingly. So this is what mentioned in your book. Okay. So when you read this also. So students, all these are there in your book, page number 184, printed page number 184. Note down, note down. Kaifali, are you there? Kaifali? What happened? Now he is not attending the lectures. Kaifali is there or not?
No,
Did he
ma'am, I think
attend? Did he attend a previous lecture?
I also don't know, ma'am. I didn't see the list, ma'am.
Students, did I share the first PPT with you?
Yes, ma'am.
Okay. What? You came now suddenly?
No, ma'am. I had kept it on mute, ma'am. Myself on mute, ma'am. My mic was not turning on. It was off from headphone only.
Okay. Why I called you? Page number I said because you said there was difficulty to find the content in the book. So 184 noted. 184 is a page number. There actually the content, the continuation, the content are starting from there. Okay. So there if you read whatever I explained, that will be there. The best fit, first fit and all there in page number 84. Now I say these are the four different cases when a process before deleting the process would be. This is also with the diagram. It is there, but the diagram I think it is not clear in the textbook. So after I shared this PPT, you can see for the picture, you can see diagrams, you can see this PPT. Okay. So page number 184, note down students, please study. Please study operating system. No, you don't think that later we will study and don't decide that, okay, I cannot study this. Don't think. Every day if you study immediately after I taught, that means immediately matlab what? The day when I'm teaching, no, that same day if you refer, it will be very easy. Okay. So these are the subject immediately you have to study. Please study. Because if the offline exam is there, then the descriptive type questions will be there. You should write. No.
Ma'am, you have shared only the PDF of first chapter, not of that process and thread.
Process and threads I did not share. But I have everything in, that one PPT, 2 PPT or what? Wait, I'll check. Huh? I will check and upload today. Okay. What already I
Okay, ma'am.
uploaded would be there in the files. No, I will check that and I will. If it is not there, I will upload. And even this PPT also I will upload. Okay. So then you can refer. But content will not be there in the PPT. Okay. Content will not be there in the PPT. It is not necessary whatever is given in the book, same way you have to type. Necessary, the same way you have to write. Okay. You just understand the concept and using your own words, you can write. Okay. Using own words, you can write. Okay. Next, virtual memory. Wait.
Okay, ma'am.
Ma'am?
Yes, time is 1:20. That's what you came to
Ma'am,
say.
I had a doubt. Ma'am, NSM का lecture online ही होगा क्या? Offline ही होगा?
NSM. No, sir used to take offline only before before pandemic. But now why he is taking in online? Already see, when Sudha ma'am said next whole week we are going to take the lecture in offline, that time the room availability did not come. Okay. So that time sir has given the schedule for offline only. But now, see, think tomorrow it's the room is not available from 1 to 6. Okay. So how can he take? Morning though he cannot because he's working in some other college. Okay. So usually when he took lecture in previously in our college also, he used to come at 3 o'clock only. Sometimes he will adjust the lecture and he will come 2 o'clock. But maximum he reach our college 3 o'clock only when he took offline lecture. Okay, till 6 o'clock,
Okay.
that is usual. Everybody knows. Even you can ask your seniors also. Till 6, his lecture will go, but weekly 2 days, no? Weekly 2 days. He will take the offline
Okay.
lectures. He will take the offline lectures, but for that, the whole day we need a room. Okay, only the morning rooms are available. He will not be able to come to college because he is a faculty of one engineering college. Because why you want to ask any doubt directly?
No, nothing, ma'am. ऐसे ही पूछा मैम क्या सब lecture मतलब कुछ lecture ऐसे हो रहे तो शायद हो जाए.
Okay, no. If you want to ask anything, any doubt or anything is there, you tell me. But even what he will do, we have to give the room, no? Then only he can take.
चलेगा मैम ऑनलाइन भी पूछ दूंगा चलो.
But 26th onwards, maximum we expect here. We will get room. We will see. Completely morning to evening, all the schedule we want to take in offline. Abhi that day what happened? 3.5 hours wasted. I thought to take lecture and when you came to college, no, you all. That day I decided okay to take the practical at least. But practical लेने के लिए that now TY practicals are there, no? They formatted the PC completely. And the LCD connected with which PC, no? That screen is not visible because this 2 years we did not use, no? So Patel was busy with formatting the PCs, so he couldn't help. So that day completely, I could not take. I wanted to take that day because I know already my schedule. Only that day, if I can take, I can take. Otherwise, now after 26 only I can take. That I know. That's why I thought I have to take. The day also after completing SY practical, I rushed and came to college. So we teachers also want to take offline, but we will see 26th onwards, maximum 26, no, 28th onwards, I think we will get a complete room. Okay, chalo, time ho gaya. I thought to complete this also, paging also, but I just start at least. I share the file. This file I gave to last year students. This I found today morning. This also I have to share with you. Isme na just a copy pasted item only. So please forgive me. Roughly I added the content, but the process control block, threads, and the difference between process and thread. This I have taken in various this to simplify. Simply you can study what is critical region, mutual exclusion. Everything I put in readable format. You please arrange. Okay. See what is CPU scheduling. All those are there. So this also I will share with you. Okay. Simply about the first come first served algorithm. Example you refer in the examples which I added in the PPT, but the theory you can refer in this. Okay. Even example also I added, I think, same examples. Okay. Chalo. Now, what is paging? Students, paging and segmentation already I mentioned. In a virtual memory, after virtual memory concept came, what we did, we needed to split the program into different segments or different pages. Difference between segment and pages are program will be splitted into fixed size units. That is called a page. Okay. For example, there is a single program. That program splitted into that program occupied 4 KB. Okay, it is splitted into 4 1 KB segments, 4 1 KB units. Okay. So now here, if you look at each and every unit, the size of the units are same. Okay. So these units are called pages. Okay. But in segments, we will split the units in different varying size. Okay. So now paging and segmentation are virtual memory concept. When you split the program into either pages or the segments, your main memory and the secondary memory, that means the virtual memory portion, should also be splitted into same size blocks. Then only when you pick up the portion of the program, a part of the program, and when you put inside either the disk or the main memory, it will fit exactly inside the space. Okay. So that the paging and segmentation has been used. In that, paging is a process of reading data and writing data, reading the data from and writing the data to the secondary storage memory. What is the need of the paging? Paging is a technique, memory management scheme, we can say. It is a memory management scheme that is used to retrieve the process from the secondary memory whenever the process needed from the secondary memory, it will be taken from the primary memory. Okay. The main objective of the paging is to divide the single process into different fixed splitting the process into fixed size units. Okay. So what is the use of the paging? Whenever we in a multi-processing system, whenever the processing starts, new process comes. Okay, the process will be in the form of page. Okay, the process will be in the form of page. Okay, if the process is available in the main memory, if the process is already available in the main memory, when it is requested by the program, when it is requested by the program, then it will be taken from directly the main memory. Okay, suppose in the main memory already it is not available, then it should be taken from the disk. Okay, if first time when we search the page is available, I am changing the term page. Okay, not process. Whenever we search the page is available in the main memory, it is called a if it is available, it will retrieve. But if it is not available, that is called a memory fault. Memory fault. Okay. I repeat the entire scenario. Okay. Your CPU. Okay, your CPU is executing a program. Your CPU is executing a program. So when it executes the program, if any part of the program should be loaded, program means then it is a process, no? So the process should be loaded in the main memory. It will be loaded. Okay, it will be loaded in the main memory. Okay, like that, assume that there are many processes which are loaded in the main memory. Now processes are in the form of page. Okay, many pages are loaded in the main memory. Now no space to store the new page. Okay, but new page content arrives. What the operating system should do? Of course, it has to remove the page from the main memory. Okay, it has to remove the page from the main memory. It has to remove the page from the main memory, and then that page should go to some address space in some location in the virtual memory, because that particular page which got removed will be needed later. Okay, so that will go to the secondary memory. Okay, now that page which went to secondary memory will not be available in the main memory, right? Assume that new process comes that occupied, okay, in one point of time, the page which went to the secondary memory is needed now. Okay, now it is needed. Now the operating system should know where I have to go and search the particular process in the secondary memory, in which address. Okay, so the address conversion is main part of the paging technique. Address conversion is a main part of the paging technique. Here, important task of the operating system is converting the logical address into physical address. Physical address will be the address locations in the main memory. Logical addresses are address locations in the secondary memory or disk. Okay. Okay. Now in paging, the secondary memory will be splitted into fixed size units. Those units are called pages. Okay, those units are called pages. Now when the secondary memory is splitted into fixed size units, we are going to exchange the data from the main memory to secondary memory. So secondary memory should also be splitted. Okay, so secondary memory, main memory, both will be splitted into fixed size units, but in secondary memory, if individual units are called page, but in main memory, those units are called frames. Okay, this is called page frame actually. Okay, page frame. Okay, in main memory, we can find the page frames. In secondary memory, we can find pages. Size of page frame and size of the page will be same always. Okay. And in paging, I said the program separately, the program will be splitted into different units. No, the size of that units will also same as the page size and also frame size. Okay, there are three things we splitted here in the paging: our programs and for main memory and also secondary memory. Okay, but we are calling by keeping separate names. That's it. Okay, in main memory, the splitted units are called frames. In secondary memory, the splitted units are called pages. In the programs, we are splitting into different segments, but we are not calling that as a segment. Okay, those are fixed splitted units. Okay, but one thing you have to remember: the size of single frame and the size of single page and the size of the single program unit, all are same. All are same. Okay. Now, when the program comes to the operating system knows the logical address. Logical address is called virtual address. Virtual address, when I'm saying virtual address, where it will be, by seeing the name itself, you can say it will be inside the secondary memory. Virtual, because secondary memory only we are using as a virtual memory. No. So, logical address is nothing but a virtual address. Virtual memory address is called a logical address. Okay. So when CPU receives any program, a part of a process in the program, it will know the logical address. Okay. The format of the logical address will be, now here only the splits I have shown. Okay. During the paging, there will be a process called mapping will happen. So our CPU will create the logical address. That logical address will be converted to physical address. Physical address will be the addresses in the main memory. Okay. Main memory addresses are called physical addresses. Secondary memory addresses are called logical addresses or virtual addresses. Both denote same only. Okay. There should be a mapping between the logical addresses to physical address. Logical address to physical address. Why? Because CPU will generate the logical address. That logical address should be converted to physical address. Why all these conversion should happen? Because here is some data. That data we have to find where it is located in the main memory. Both the address will not be same. Why both the address will not be same? Because main memory is a small memory. Secondary memory, our virtual memory, is a big memory. Okay. So wherever in which location we are storing some data in the main memory, in the same location we cannot save the data in the secondary memory. That will be stored in a different location only. So address mapping should be done whenever we are swapping the data from the main memory to secondary memory. Okay. So this is one of the important process will be done during the paging. Okay, why it is called paging? Because the secondary memory, the virtual memory, is splitted into different pages. Okay. So the pages will be transferred to the main memory, and pages will only be come back from the main memory. Okay. How in swapping, the entire program will go out of the main memory and come inside the main memory. Same way here, the portion of the program is called page. No, so page only, the whole page content will go inside the main memory and come out of the main memory. Okay. Okay. So now here the mapping, how the mapping is done, that you have to see how the mapping will be done. Okay. Students, you understand why the mapping is required. We have, students, please listen. We have small RAM. Sorry, here it is RAM. We have small RAM. We have very large virtual memory. Small RAM, large virtual memory. Okay. And in the small main memory, whatever content is there here in the virtual memory, everything we cannot load. Okay. Everything we cannot load. Assume that now this is one program. The program is splitted into 5 pages. Okay. all these 5 pages will not be there in the main memory. Okay, whichever page, why we are splitting the program into pages? Because only the portion of the program can only go to the main memory. Okay, so at any point of time, if you see any 1 or 2 of the pages of a particular process will be only there in the main memory. Everything we can't load, then of course it will be equal to swapping then. Okay, so when we are storing the same data in one location, one memory in one location, okay, the same data we are bringing to the main memory in different location, how the operating system will convert this address to this address to find the data. That process is called a mapping. Okay, how the mapping will be done? As I said, CPU will have logical address. Remember, CPU will generate logical address. Logical address is very simple. Students, you are studying microprocessor. Whatever program you are typing, no, that will be converted to assembly language. Okay, assembly language may you might have seen that move 100, comma a, that denotes what? Some data in the location, in address location 100, you are moving to accumulator. Okay, so there we are mentioning the address. No, we are not mentioning. We are a high level programmer, so we will write the program in high level language that will be converted to assembly language. So assembly language will have instructions. Okay, inside the instruction there will be many addresses. Those addresses are called logical addresses. Those addresses are visible to the CPU, known by the CPU. Okay, so that will know logical address, but in our main memory we have a physical address. Okay, okay. Now see, in the paging, the address mapping will be done like this. Okay, this is very important question, students. CPU, there is a CPU. Okay, CPU generate logical address. Whenever a process created, it will create a logical address. Logical address will have page number. Page is where page will be there in virtual memory. Remember, okay. Logical address will be splitted into 2 segments. One is page number. Another one is called displacement, but usually this is called as offset. OFFSET, offset. Page number, offset. Okay. Page number, you know that the page number will be the page number in the virtual memory. For example, virtual memory may previously I showed page 0, page 1, page 2, page 3, page 4. That number is here. Okay. But the page number will be there in the form of binary format. Okay. All the addresses and the data, everything will be there in binary format only. Remember. Okay. So logical address has 2 segments. Who will create logical address? CPU knows the logical address. Okay. So CPU only created the logical address. Logical address has 2 components. One is page number. Another one is, because logical address is a disk address. No. So it's a virtual address. Okay. So only per page number will come there. Okay. So it will have page number and the displacement number. Displacement is nothing but offset. I will tell you what is offset. Okay. So there are 2 different numbers combined called logical address. Okay. One is page number, another is offset. Okay. Now the page number. Now this page number and the offset is given in the logical address. By taking this logical address, we have to convert this logical address to physical address. Okay. Why we have to convert the logical address to physical address? Because this content, I have to see this content is already there in the main memory or not. Okay. So when I'm searching in the main memory, in which address I will go and see whether the content is there or not. For that, I should know the exact address, no? So that address is this. Okay. So this is called physical address. In the physical address, there will be a frame number, Where the frames will be in the main memory only, remember. Okay. So frame number and same offset. What is that here? That will be there. These two components combinedly called a physical address. Remember, logical address will be address of the virtual memory, which is nothing but a disk address. Physical address is the address of the main memory. Okay, address in the main memory. Now, logical address is given. Who give the logical address? When the program is getting executed by the CPU know the logical address. So, logical address will be given by the CPU. Logical address will have two parts. One is page number, another one is offset. Okay. Now, this logical address should be converted to physical address.
Hello, ma'am.
Time is over.
Yes, ma'am.
Next lecture at what time?
2 o'clock.
2 o'clock,
2
ma'am.
o'clock, ma'am.
So lunch you have to have.
Yes.
Oh, already messaged, but I did not see the message. Okay. Okay, students. Thank you. You all can leave.
Thank you, ma'am. Bye.
Thank you, ma'am.
Bye.